Mr. Gustin. I'm actually not in the physics classroom today. I'm in a biology classroom, so this feels weird, but we're in here anyway. All right. During seminar today, here's what we talked about. I started with this problem where there's a pulley and a mass hanging from it. At part A, the pulley is a disk, so its I value is 1/2 mr squared. And then I drop this mass. When I drop the mass, the pulley starts to rotate. And I asked students to write out me a conservation of energy expression. So initially I got UG because the system's at rest, the mass is above the ground is down there somewhere. After the mass falls and before it hits the ground, it's moving linearly, so there's translational kinetic energy, and the pulley's rotating, so there's K rot. I went ahead and started solving, and I made a common physics mistake. I went ahead and I plugged in my base variables for UG, for KT, and K rot, and I saw something. I saw that every term had mass in it, and I said to myself, hey, that's pretty sweet. Let's just drop out mass. My question to you all is, why is this wrong? Why can I not drop out the mass for each of those? In order to figure that out, we need to analyze these energies a little more carefully. So this UG was UG for the block itself. The block was above the ground. We're analyzing that UG. This translational energy, the object moving linearly when the system is let go, is the block as well. So this is KT block, UG block, but K rot is not the block, right? K rot, the rotational kinetic energy, is not stored in the block itself. It's actually stored in the pulley. So this K rot is like K rot of the pulley, which means when I start putting in my base variables, this is mass of the block, this is mass of the block, and this is mass of the pulley. Even though they had the same variable, M, they're different masses. One's mass B, one's mass P. I can't do this. This is such a common mistake. So how do I avoid this mistake? How do I make sure when I am doing a lab formative or a summative that I avoid making this kind of mistake? Well, do what I did and make sure you're super specific. Make sure you are overly specific. Make sure you say, hey, this is UG for the block. This is MG for the block, or M block. This is M block, this is M pulley. Make sure you're giving one extra subscript to identify which variable that truly is. Like I said, I'm in a biology classroom. Apparently they don't have erasers in biology classrooms. I guess I may just have to use my sleeve. Found one. Got it. Here we go. Let's try this problem. Let's go ahead and try this. Let's see how wild these equations can get when we have different masses or things rotating and moving linearly at the same time. Let's try this. Here's a new mass. This is a mass pulley. Hanging from there we have mass 1. We also have mass 2. They're at the same height. This is T2. This is T1. Let's say mass 2 is larger than mass 1. My first question is, which tension is larger? If mass 2 is bigger, which way is the pulley going to rotate? Which way is the mass going to fall? Good. If you said T2 is bigger, you're absolutely right. T2 is absolutely bigger. It's going to fall a height of h. All right? This pulley is going to end up rotating this way. Let's write a conservation of energy expression. We have UG for the mass 2 plus UG for mass 1. They're both above the surface of the earth. They're both there. Nothing's moving, so those are the only energies that we currently have. After it's moving for a while and mass 2 is about to reach the ground, well, now we have got the kinetic energy for 2 because it's down. M1 is actually higher, so we have UG on 1, but it's also moving, so we have kinetic energy on 1. So we have both of those. And then so we have this one, we have this one. We also have our last one. We also have K rot for the pulley. Let's go ahead and try and derive an expression for the final velocity of mass 2. Let's figure out what that is and work our way there. We may not get to the end of this thing because it's going to get wild, but we're going to see why using subscripts is so important. So let's start. So M2GH plus M1GH, those are my UG equations, is equal to 1/2 M2V squared plus M1G. Now, how high will it be after this thing falls H? Well, it starts at H, and M2 falls H, which means M1 has to raise a height of H. So its new height is 2h. Plus 1/2 m1v squared plus 1/2, I'm going to go ahead and say 1/2 m poly r squared times omega squared. Whoa, that got weird. Times omega squared. Okay, let's start simplifying. Let's start seeing if we can plug some things in, cancel some things out. The first thing I would do, because I'm trying to solve for final velocity, is I would immediately use the concept in physics with the bridge equation, right? Like this pulley is going to rotate. And when it does rotate, it's only going to rotate as fast as this thing is falling. And it's only going to fall as fast as this thing is rising. So they're all kind of linked. All the velocities in this equation are the same. Let's go ahead and bridge this variable over here. Instead of omega, let's call it v over r squared. And let's just go ahead and distribute that square right off the bat. Let's go v squared over r squared. Now when I have that, I see my r's cancel out. Wonderful. Let's rewrite this. m2 g h plus m1 g h is equal to 1/2 m2 v squared plus m1 g times 2h plus 1/2 m1 v squared plus 1/4, woo, algebra, 1/4 mp v squared. Folks, do you see the number of masses in here? Do you see how tempting it would be to be like, mass cancels out, make this thing so much easier? It's so tempting to take those masses away, but there are 3 different masses in here. We cannot do that. So instead, we have to get down and dirty with the algebra and go ahead and try to isolate v squared. It's wild. It's nuts. Give it a try. I'm less concerned with you actually getting me an answer and more concerned with you understanding why it is so important to label your mass values. Label your mass variables. Label your mass variables so that you are not tempted to cancel them out. The rest of the seminar, go ahead, derive the expression for v. Isolate v. It's wild. Good luck.